Hey, this is Mr. Ariel. I'm here today with some density practice problems. Make sure you've got the sheet with the problems on them and something to write with, and a calculator will be helpful as well. Let's get started. All right, on number 1, we want to know the density of water if 10 grams of water occupies a volume of 10 milliliters. Well, the formula for density is equal to mass divided by volume. And so if we need to solve this, I know that grams measure mass, and the volume is given over here as 10 milliliters. So let me just plug those in. Density is equal to 10 grams. That's going to be divided by 10 milliliters. And of course, that works out to be 1. I don't even need a calculator for that one. And those units would be grams per milliliter because nothing cancels out of that problem. Now, if you're wondering if that's just a coincidence or did science set that up, that it's exactly 1 gram per milliliter, it's a setup. Back before accurate scales were really common in the world, measuring a volume of water was used to establish the unit of mass because everybody could accurately measure water, whereas measuring mass was much more difficult. So 1 gram of mass was set to be equal to the mass of 1 cubic centimeter of water. Now, one other thing about density, this unit right here, grams per milliliter, that's for liquids. And you probably know that 1 milliliter is equal to a cubic centimeter. And so for solids, you're going to see the unit written as grams per cubic centimeter. Don't get confused. Sometimes in science, we have a lot of names for practically the same thing. Let's move on to the next question. Now, question 2 says, what is the mass of a piece of wood if it has a volume of 45 centimeters cubed? So that's volume. And over here, we have the density given as 0.52 grams per cubic centimeter. Well, I always like starting these problems just by writing down the formula. A lot of times it might seem too easy to you, but it's an easy way to prevent a simple mistake. So I'm going to plug in my numbers. I know that the volume is 45 centimeters cubed, and I know that I'm wanting to figure out the mass, and so that goes back over here. And then I'll put the density over here as 0.52 grams per centimeter cubed. Now, because I'm trying to solve for mass and I have 45 over here, the next step is to multiply the 45 to both sides. And of course, it will cancel out on the right. So let me write that again. That's going to be m. And if I check my calculator, 45 times 0.52, that works out to be 23.4. Now for the units, I always like to work those out separately. What we just did is we took a unit of grams over centimeters cubed and we multiplied by 45 centimeters cubed. So that's up in the numerator. And if you can see that, the units just canceled out. And so now we have grams, and that's the appropriate unit for mass. It's just kind of a sign that we did the work correctly. So moving on, we have question 3. What is the volume of a piece of metal if it has a mass of 50.2 grams and a density of 8.24 grams per centimeter cubed? So again, I like to write that formula down first, and then I just plug in the numbers. Density is 8.24 grams over centimeters cubed, and that's equal to the mass, which is 50.2. Make that decimal a little more clear, and we are solving for volume. Now, this problem always looks simple to a lot of students, and then you end up wrestling with it quite a bit. And the only way I know how to teach you how to do it is that you have to multiply both sides by v. Now, I actually want to back up on this. Don't write this next part down. The most common thing I see students do to try to solve for v is they multiply both sides by 50.2 grams, and they think that's algebra. But if you notice here, 50.2 times 50.2, that doesn't cancel out. But I'll see students cancel it out. They think they're right, and then they get really frustrated with me. And let me show you another thing that students often do wrong with this problem. Just trying to save you some of that frustration. A lot of students will solve this problem by dividing both sides by 50.2 grams because they know that will definitely cancel. And they do the same thing on the other side because that is algebra. And then they solve that problem and they say that v is equal to whatever that works out to be on the calculator. But if they were to slow down a little bit, these students would realize that dividing a number by itself is equal to 1. And so now they would say that's 1 over v is equal to whatever this math works out to be. And that's not the same thing as volume. This is the inverse of volume. Or I think some people might say it's the reciprocal. So let me clean the board back up to where we need to be, and I'll show you how to solve this problem correctly. Okay, so here we go. The correct thing to do, as I said earlier, is multiply both sides by volume, because volume will now cancel out on the right-hand side. And I always recommend writing this one more time. just for clarity to avoid confusion. So that's 50.2 grams. And at this point, most students pick up pretty quickly that we're just going to need to divide both sides by 8.24. If we did that to the left, we have to follow it up with the right. And then, of course, this part will cancel out entirely, and V is equal to 50.2 divided by 8.24. And so by sig figs, all these numbers have 3 sig figs, and so I'm going to round my answer back to 6.09. And the unit should be centimeters cubed, but let's just work out the math on that to make sure we're doing things correctly. What we just did is divide grams by grams per centimeter cubed. I mean, basically we did this. And my high school algebra teacher taught me that dividing anything is like multiplying by the reciprocal. But I think the more modern form might be called keep, change, flip. You keep the first unit right here, you change the division sign to a multiply, and then you flip the last fraction. So that's centimeters cubed over grams. And just like that, grams cancel out, and that leaves you with the unit you would expect for volume. And so that is the finished answer. Moving on to problem number 4. We've got a block of wood 3 centimeters on each side, has a mass of 20 grams. What is the density of this block of wood? And so we're looking for density. We know the mass is over here, and this measurement right here is basically a length, a width, and a height. And so for this problem, we're still going to use density is mass divided by volume, but this volume down here is simply length times width times height. So let's start plugging in some numbers. That's density is equal to the mass of 20 grams, and I'm simply going to divide by 3 centimeters times 3 centimeters times 3 centimeters. Or we could just put 3 to the third power. Now I'm going to simplify that a little bit. That's 20 grams, and 3 times 3 times 3, that's 27, and that would be centimeters cubed. And so now I just need to divide 20 by 27. Now back to these original numbers, this one only has 1 sig fig. And these down here have 2. And so if I'm finishing up the math on this, my answer can only have 1 sig fig. And so that's going to be 0.7 grams per centimeters cubed. None of those units cancel out. Now we got 2 more problems, so let's get into it. We have an irregularly shaped stone that was lowered into a graduated cylinder holding 20 milliliters of water. Let me kind of draw that in on my graduated cylinder here. Let's just pretend that was 20. And then after dropping the stone into the water, the new level of the water is 27. So I'll draw a new level right up here and say that's 27. If the mass of the stone is 25 grams, what is the stone's density? So we know the formula for density is mass divided by volume. And so let's start plugging in some numbers. We've got density is equal to the mass, that's 25 grams. And we're going to divide that by the volume. Now, if you're wondering which of these is the volume that we need to plug in, it's not either one. I'll label this one as original volume, and then this is final volume up here. And neither one of them is the actual volume of the rock. By the way, that would be sitting down here at the bottom of the container. What we need to solve for instead is the change of volume. In science, we write that as change. It's a delta sign. And so that's change of volume. It's going to be equal to the final volume minus the original volume. You'll see this notation quite a bit in science. And so if I just plug in those numbers, the change of volume is going to be equal to 27 milliliters minus 20 milliliters. And so that works out to be 7. And that would be 7.0 by sig figs. So I'll plug that number in over here. And then to finish up, 25 divided by 7, that is 3.57 on the calculator, but because of sig figs, this number up here only had 2 sig figs. That's going to give us an answer of 3.6 grams per milliliter. All right, we have one more problem. Let's get into it. During a lab activity, a student measured the density of an object and found it to be 4.55 grams per cubic centimeter. The student then looked up the known density of the substance in a reference table and found it to be 4.62. What is the percent error for the student's results? Just copy this formula down into your paper. That percent error is equal to an observed value minus the expected value, all divided by the expected value. And then that's multiplied by 100 to turn it into a percent. So let's just plug in some numbers. So the observed value is what the student saw, that it was 4.55. And then the expected was 4.62. And so we're going to divide that by the expected value. And I'll close that parentheses and multiply by 100. So percent error is going to be equal to the numbers on top are subtracted, so that's 4.55 minus 4.62. And so that numerator works out to be negative 0.07, and that's still grams per centimeter cubed. We're still dividing by 4.62. And let's not forget to multiply by 100. Now right there, you can see the units all cancel out because we're dividing a unit by itself. And so now to finish that up, percent error, that's negative 0.07 divided by 4.62. That works out to be negative 0.01515, and it just keeps repeating after that. And let's still not forget to multiply by 100. And so our finished answer over here, let me multiply by 100, is negative 1.52%. All of these numbers have 3 sig figs, and so our answer is rounded back to 3 sig figs. So let me put a percent sign on that. And I want to mention this negative sign here. A lot of students get confused about what percent error means, and the best percent error is 0% error. And negative percent error just means that the student's value up here was slightly less than the accepted value. And if they had found a bigger value than this 4.62, the percent error would have worked out to be positive. So negative's not bad, and positive's not good either. Ideal percent error is 0. Now we have 0 things left to learn in this lesson. I hope the video has been helpful to you today, and as always, thanks for watching.